Hope you all are enjoying the delightfully enriching, engaging discussion so far. Let's continue the momentum with our next panel discussion on analyzing the impact on vehicle safety driven by connected technology. When we talk about safety security in a connected vehicle, we mostly focus on cybersecurity. But today, we are not only going to talk about cybersecurity, but we are also going to talk about how will the scenario in a connected vehicle change when it comes to active and passive safety and security. And to discuss this, I have a perfect battery of subject matter experts today. Let me introduce to you Mr. T.N. Umamaheshwaran, Head Digital Product Development Systems and Strategic Business Planning at Tata Motors. We are also joined by Mr. Omkar Panse, Head Digital Connected Solutions, KPIT. Nakul Cooker, CEO and co-founder of Cell Proposal. We also have Mr. Raghvendra Bhat, a technical consultant, Ansys. We are also joined by Mr. Khushwant Pawar, Head Cybersecurity Solutions, Mobility, Regional Market, India, ETS Automotive India Private Limited. Thank you so much, gentlemen, for joining in today's very pertinent subject of discussion. We talk about safety, security. I'll just go to Mr. Umamaheshwaran because he is the OEM. He manufactures the vehicle and he is probably the center of the entire value chain to understand how will the connectivity in a vehicle going to change the safety and security of vehicle. How is it going to be a beyond dealing with the cyber security? Do you expect that the traditional safety aspect is also going to improve with the connected vehicles?
If you see from a Tata Motor perspective, okay, from a OE perspective, we have got two responsibilities. One, we have to keep the data safe of all the end users, of all the end customers. So the cyber security is paramount. So because of that, you can see all the hosting of our connected vehicle platform is on a public cloud, which is certified by ISO 27001 kind of a standard, where they are in a position to keep the both confidentiality and the cyber security from a platform point of view safe. The second comes the privacy and data security in vehicle and how the data gets transmitted from the vehicle to the backend cloud. So we have 100% encryption with private keys in Tata Motor landscape, which is so every vehicle, our TCUs are having dedicated certificates. It's not open. It's not possible for anyone to crack the data. It's transmitted by the Tata Motor TCU. And coming to the in-vehicle electronics, that is in onboard the vehicle, we have already have enough set of issues in our hand. It's not so easy to solve. For example, Bluetooth hacking, or someone can fiddle around and open the remote of your car to some other means, because the security levels historically on onboard electronics was a bit weak. So we also suffer from the same those kind of issues. We are trying to work with our partners, with various suppliers of our equipment to enforce layer 1 or that in-vehicle electronic security also. So broadly speaking, the data security for us is in multiple levels. So I explained you all the three layers for you. And coming to the functional safety, in Tata Motors, before we launch any function, we go through the ISO 26262. There's an ISO standard which talks of automotive functional safety. Automotive functional safety is what is the paramount discussion, not only for mechanical system, electrical system, or electromechanical system. All three combinations have to adhere to the functional safety of anything. For example, if you take even ABS, the braking has to work irrespective of the connected vehicle. So we look at connectivity is adding to some more dimensions to our functional safety aspects. So we have to keep all these things in mind before we launch any function. But of course, whatever data we are gathering now is going to enhance the quality of the product over a period of time. It is new. Connected vehicle is new for not only for us but for the entire world. New ideas. In fact, there is one work going on within Tata Motors how to eradicate sensors and create virtual sensors. Whereas there's no need to keep sensors for everything, but we can derive some data out of already known data. So that becomes an interesting way by which we can virtualize the sensor itself, thereby reducing the complexity of the in-vehicle electronics. So these are some of the research topics which Tata Motor R&D, where I belong to, the research center, engineering research center in Pune. we are focused on doing this kind of activity. While we create this technology and hand over to the business uses that for serving the needs for the day-to-day end customer, be it a fleet owner or a driver or end customer who wants to know the nearest cafe coffee day or nearest Starbucks cafe where it is. It's interface with the ecosystem to give more function and features, basically come more oriented towards comfort.
Yeah,
Coming
vehicle.
to coming to functional safety. Functional safety is what from R&D side we focus on how to ensure that whatever we are giving is not a distraction to a driver. It should not create unnecessary alarms. We are trying to see the usage policy and how loud certain alerts should be and whether the messages can be buffered and delivered to the driver at an appropriate time when he can going at a much lower speed. These are some of the delayed way of information dissemination. Also will prevent road accidents. They are basically comes under our functional safety initiative.
Thank you, Mr. Umamaheshwaran. I'll come to you, Mr. Raghvendra. I just want to understand at the basic level how the scenario in terms of design and development is changing for the passenger vehicles or entire automobile products, be it trucks or bus or three-wheeler, when connected and autonomy is going to grow hand in hand. In such a scenario, there is going to be an increased chances of security threats, and with the increased number of electronics, human intervention going to reduce with autonomy coming up. In such a scenario, how the safety security is being taken care by all these OEMs, because you deal with them directly, you provide the software and solutions for these design and development. How do you see the landscape and what kind of major challenges you see?
Well, the safety and security are two important things that we need to consider in case of any road vehicles dealing with today. Safety has been a consideration for a long time. Like Mr. Umamaheshwaran has talked about, there are lots of automation and functionalities that we see in today's vehicles. It could be emergency braking system, or it could be anti-lock braking system, or any other system that we're talking about. So all of these systems need to go through systematic analysis from the safety perspective, and ISO 26262 is a guideline that's being used worldwide for analyzing the safety of the functionalities. Now, talking about specifically the connected vehicles. Now, we are talking about the vehicles that are intelligent, that can establish communication with, let's say, other vehicles on the road, or maybe other components from the infrastructure. So during this time, what really is happening is that we are adding more and more electronics, we are adding more and more software to enable this communication with the rest of the infrastructure. Now, one of the important aspects of the security is that when we have more of these interfaces that are opened up, it kind of provides a higher or the bigger canvas for someone that is intentionally want to get into the system, right? So this is one of the important challenge that we see. And we do not probably talk about connected vehicles as in isolation, because connected vehicles, driver assistance systems and autonomous driving, all of these technologies are going forward in parallel to each other. So that means the connected vehicles are also going to be ADAS enabled, and in the future, they are going to be autonomous systems, which means these vehicles are going to have much larger amount of electronics, much higher amount of software in them, which is kind of opening up much a bigger canvas for somebody to hack into them and exploit the vulnerabilities that are present in these systems. So this needs to be dealt with systematically.
Thank you, Mr. Bhat. Omkar, I'll come to you. Mr. Bhat rightly pointed out the vulnerability that is going to come out with the traditional features, electronic safety features like EBD, ABS, or all that. But I also think that the connected feature or the software, as these things become more intelligent, do you think that these feature will further become strong and it will have positive impact also on the vehicle, or your expenses will come down in terms of developing safety network in a vehicle with more of connectivity coming in into vehicles?
Yeah, I think absolutely. I mean, see, connected is a very, very promising trend. And on one hand side, users' lifestyle is increasingly connected. So you can hardly keep connectivity away from it. So simplest features which enhance the customer experience dramatically. Things like, Amazon making deliveries right into the car. It is made possible because of the connecting and, connecting all the dots. So that's a delight as a customer that I get. At the same time, the connectedness exposes car to the external world. And all of us know car is a very, very complex cyber physical system. So it's not like any cyber virtual system. It's a cyber physical system. So there are significant potential downside impacts that can happen. But at the same time, connectivity also brings a lot of promise with it. For example, only because of connectivity, it is now possible to build features, things like, let's say, creating a digital buffer between the two cars. You have got things like, let's say, ABS. You have got things like adaptive cruise control, which help the car, either maintain the distance or maintain kind of a braking distance. But that can be now taken to the next level as what we at KPIT call as a digital buffer, and that digital buffer will be enabled by exciting new technologies like 5G networks, computing that will be happening at the edge of the 5G network, and enormous possibilities it will unfold. So the combination of autonomous driving combined with connectivity will actually also have a very positive effect on overall automotive safety. And I think it will make these systems, autonomous driving, ADAS systems, and all the driver assistance systems more smarter. And of course, they don't become smart automatically. You have to follow all the norms that Mr. Raghvendra and Mr. Umamaheshwaran talked about. You have to adhere to functional safety norms in terms of how do you write the software, how do you validate the software, how do you make sure that there are no kind of uncovered paths in your software. Only then you can rely on that piece of software. And what better example in the recent times that what we saw happening with the Boeing 737 MAX aircraft, right? It was a software that was added to enhance the functionality and assist the pilot, but it kind of worked quite counterintuitively. So yes, it can have significant positive impact, provided the rules and regulations and the methodology is kind of adhered to. So we at KPIT are terribly excited about the possibilities 5G and the connectivity will unleash to positively improve the safety and make the experience inside the car far more enjoyable, whether you're driving by yourself or together with family. So there's certainly positive things. And of course, it could eventually help also optimize or change the cost profile of all the things. Things like virtual sensors that we heard about. The more we learn, the more intelligent decisions can be taken. It doesn't mean that the fundamental mechanical sensors actuators are going to go away. They're probably either going to become smart or they're going to get consolidated, or in some cases, some sensors might just totally disappear. But again, we have to keep in mind that the mobility landscape is also shifting very rapidly to electric mobility. And by definition, the electric car has far less moving parts in it. And it's a far less complex system. And it kind of makes implementation of safety and security better while keeping in line with the advantages that connectivity would bring. That's our view.
I'll come to you, Khushwant, and understand vehicles are going to be connected with the open environment also. Like when we talk about V2X, we talk about vehicle to infrastructure. How are you going to control those open environment when it comes to cybersecurity? How are you going to deal with those challenges? Because vehicle can be used for any purposes, like terrorist or anybody can use the vehicle as a weapon also. You might control your vehicles, but how will you control the open environment? Like Mr. Umamaheshwaran was mentioning about you going to CCD or any other place trying to connect to those kind of or a retail shop or something of that sort. How will you control those aspect of safety and security? What are you guys doing in that?
One part about connecting to the external world, multiple interfaces. We are talking about, not single interface, but multiple interfaces for external connectivity. But we have to isolate these two parts, the external connectivity and its impact, until the attacker is able to enter into the vehicle. That's one part. Second part is what happens purely inside the vehicle, because inside the vehicle there are, as I think Omkar mentioned, moving parts, non-moving parts, software, hardware, and their malfunctioning, active and passive safety systems, and functional safety hazards that can occur. All of this are totally dependent on how the security is implemented within the vehicle. whereas the external environment is more dependent on how the security is implemented at the enterprise level. Now, obviously, the driver in the vehicle, or for example, the OEMs and the tier ones, they cannot control the external network environment. A simple thing is any information that goes to the cloud backend, it makes several transitions from wireless to fiber optic to again wireless, maybe long range C cables if there are the clouds are situated in US or elsewhere, maybe Frankfurt AWS cloud. So all of these means that you cannot have a coherent security measure across all of these suppliers of information exchange. What you can do is you can rely on the standard which are there, like a secure tunnel, irrespective of the medium. And that's already established. That's TLS 1.2 or SSL, for example, is a pretty established standard. Of course, there are some threats and vulnerabilities that will keep on coming up. But the bare minimum requirement is to have a secure tunnel and then VPNs and then inside the vehicle defense in depth. Because once an attacker has entered the vehicle, he will definitely have a lot of impact on other active and passive safety systems. And that's where the role of security by design comes into picture. And also, as Mr. Umamaheshwaran mentioned, that it's not only limited to designing a secure system, but also monitoring it with some digital sensors. So there is some work, of course, we are jointly doing in TML. So an intrusion detection system and a backend which can support with forensic analysis to prepare for security incidents. So to summarize, controlling the external network environment is not practically possible for anyone as of now. Even LTE has been proven, breachable, and 5G, it's in evolution. We will have more 5G towers than we had 4G towers. Like it will be like bigger lampposts or something like that. That's what is being expected. So obviously there will be more transitions the vehicle makes, not in OEM's control, definitely. So it is better to protect the vehicle and come up with measures in case of attacks. I think that's the strategy.
Thank you, Khuswant. I'll come to you, Nakul. You provide infrastructure, right? Uh, wherein these connected vehicles are to be produced, right? Now, in such a scenario, what are the key aspects to be taken care of for the vehicle manufacturer when they are producing or building vehicles which are going to operate in a connected environment?
So, Nabil, we are essentially exclusively focused on production of electric commercial vehicles and developing connectivity solutions for the large number of fleets of such vehicles. So, when we talk specifically about electric vehicles, connectivity is an indispensable part, but and not an add-on, because the battery, which is like the one of the major components, need a constant monitoring throughout its entire life cycle. So that constant monitoring of battery health over years and ensuring its performance as well as safety is one of the major electric vehicle safety features that is being enabled by connectivity. And then when we look at deployment of these vehicles in logistic fleets, then connectivity enables it has conventionally enabled vehicle tracking and geofencing and fleet management. But when it comes to electric vehicles, it also enables over-the-air updates to enhance the performance of the vehicle, as well as implementing a host of ADAS features. So we see connectivity as a tool which will enable all these things and help us deploy these in the fleets and the vehicles that we are building.
Thank you. I'll come to you, Mr. Raghvendra, once again and understand what are the key challenges globally that the connected vehicles are facing in terms of safety concern or security concern, and how are you guys dealing with it? Because you are supplying to most of the OEMs around the world. So in such a scenario, you are much more updated about the major concerns, because in India, connectivity is still picking up. We do not have that greater level of connectivity, and even users are very less of connect. Even there are connected features in the car, users are very less. So what do you hear from your global partners?
Okay, yeah. That's a very interesting question. So the first thing that we have to keep in mind is that we cannot really separate the safety and security as two different aspects, because let's say you have emergency brake as a system, and if somebody manages to get into your car by whatever mechanism possible, he can actually tamper with the system and then void your safety. So this way, the security and safety are going to go in parallel. Now, whatever is the challenge with regards to security is also in some way going to affect the safety of the vehicle at certain level. Now, keeping this in mind, when we are talking about the connected vehicles, like we just discussed in the past, so there are many ways in which somebody can exploit the security features that are built into the vehicle and gain access unauthorized. And once somebody gains access into the car, then what they can really end up doing is totally up to the imagination of the individual, and it's at with nobody's control. And like Mr. Pao was talking about just before, what happens with the infrastructure is not really something that's in our control. But we definitely still have to implement safety and security features in the vehicles that can tolerate the kind of situation that can we possibly expect from happening from the infrastructure. Now, what we see globally is that today the safety has been pretty well established. ISO 26262 as a functional safety standard is been pretty well understood and followed by most of the OEMs, no, rather not most, rather all of the OEMs and tier suppliers, rather the entire ecosystem of the automobile world pretty seriously implements ISO 26262 standard. And at the same time, there is another standard for the security side, ISO 21434. So this standard is coming out now, and this particularly advises the approach that we should take to implement the security aspects in a vehicle. Now, when we are talking about the security aspect, we could look into it from two different perspectives. The first level, we try to analyze what needs to be secured in a vehicle. So what is an asset in a vehicle that needs to be secured, and what are those attributes of the vehicle that needs to be secured, and who does it really matter to? The stakeholders, basically. So we might always think that the stakeholder is the person who's owning the car or the person that is driving the car, but that's not really true. There are multiple stakeholders that we can visualize in a vehicle ecosystem, and OEMs definitely in many cases are stakeholders as well. So we need to understand at the first place what can be, what is an asset in our infrastructure or the vehicle network, and what kind of vulnerabilities are possible, and how these vulnerabilities could be exploited, and who does it matter to. That is at the first level. And once we understand the possible vulnerabilities in our vehicle, the next step is to understand what we deal with it, and or how do we deal with these vulnerabilities. Now, obviously, there are multiple vulnerabilities that might exist, and treating all those vulnerabilities may be beyond anybody's reach. Now, we need to do the prioritization, like what is the topmost priority of the vulnerability that we need to address, and so on. And once we do the prioritization, the next step is to see how exactly we are going to go ahead and do this implementation to address these vulnerabilities. Sometimes it may be possible that we could put in some technical measures in place to address this vulnerability. And in some of the cases, it probably is not worthwhile to put in that kind of mechanism because it either is too expensive or it's too time consuming. It's just not practical enough. Or in some cases, we might say that this feature is too risky. Let's just not put into the vehicle. So this way, there are multiple ways we have to take to mitigate the risk that is possible in the vehicle. And typically in our customer scenario, we see that the people are taking both these approach. The safety is done in parallel, and security analysis is also done in parallel. And to start with the security analysis, what we do is to look into the vehicle and the entire context of the vehicle. So when we are talking about the context of the vehicle, it's not just the vehicle, rather all that is connected to the vehicle. You talked about in the past about the vehicles being connected to other vehicles, they're being connected to the infrastructures and so on. So we try to identify what are those points or the interfaces through which the vehicle can talk to each other or talk to other objects in the street. And from this point, we try to systematically analyze what are the assets that I need to protect, what are the attributes that are important for me, and who are the stakeholders that concern with these attributes, and how do we go about fixing these issues in or the vulnerabilities that are present in our vehicle. So this is a kind of systematic approach that we see are being taken with our customers globally.
Thank you, Raghvendra. I'll come to you, Mr. Umamaheshwaran, and understand how data that will be derived from connected vehicles is going to help the end user in entire life cycle when it comes to safety and security. What are the ways and means how the OEMs are trying to use these data?
Just to give a brief reply on that. First of all, if you see our existing systems, they're basically designed once, and very limited feature or function upgrade is possible over the life cycle of the vehicle. For example, you have an audio system. More or less all the audio functions are fixed. Only some media, that is basically the tracks and all, can come through multiple interfaces like Bluetooth or USB or through other means which can enter into the vehicle. Whereas now, as we evolve over the life cycle, for example, how do we ensure the ABS calibration files can be updated over a period of time based on the wear and tear of the vehicle, and so that we'll be in a position to give as good effective performance of the ABS system over the life cycle of the vehicle, and also give intelligent warnings, as I explained in my earlier talk about virtual sensors, where based on the data we have gathered over a period of time, how to create certain breakpoints which will alert the user and also the service engineer as to what parts need to be changed based on side effects of the data which you have observed. So this is basically the way OEMs are going to use the data for better life cycle management and also the maintenance, reduce the maintenance cost of the for the user, and thereby we'll be in a position to give more, maybe better warranty terms to the end customer. So this is the way the data which we gather from the vehicle is going to be having long-term effect on the vehicle owner. Coming to the OEM itself, the data which we gather is going to be having a lot of importance in designing the next generation system. So today our system is say at level 1. So obviously as we proceed, if you've seen in our automotive evolution, the total number of regulations which are getting added per year is it's not like Moore's law though. It is increasing over because of various other aspects of functional safety and new kind of road accidents, new autonomous or the new ecosystem evolution. So all these things are adding to new set of regulations which the OEM has to adhere to. So this is actually causing too much amount of evolution in the hardware also. Thereby we'll be in a position to use this past learning, also collective learning coming from various other our own equipment which is actually operational on the road, to improve our system. We call this as open loop system, where the data is coming from the vehicle, but it is not used to give the feedback to that specific vehicle, but used for future R&D and future development for making safer vehicles. Coming to the third category, that is basically coming to the ADAS, active safety. Active safety is actually we have got a lot of linkages to the machine learning. Machine learning is one very important aspect, which is actually where this data which we gather using connected vehicle is going to be the most hungry beast, which is going to rely on the data coming from the connected vehicles. So machine learning algorithms which we're developing now, we are trying to give our friend mentioned about FOTA and also battery life. So how to ensure the updates to a subsystem to be done systematically using FOTA, and how this FOTA upgrades or parameter files can be upgraded is again based on the data which we gather from various fleets and also other new additions and new regulations we are getting to give the enhancement to the user. So many times I've also given in some conferences some examples. It's not so easy to upgrade a firmware in a car like we do on an Android phone or an iPhone, because the end effect there is only audio video and it's not going to cause any side effects or any harmful situations in case the app upgrade or the iOS upgrade fails. Whereas in a car, it is going to be having a lot of other detrimental effects in case the photo doesn't go through systematically and properly. At the same time, the cost of the amount of changes which you can do in a software, keeping the hardware fixed and computing capability on the edge device fixed, is also becomes a constraint for the new generation algorithms to play, or new techniques to be made available on the vehicle itself.
You talked about changes in the hardware also after with the enhanced connectivity. Can you put some more light on this? What kind of changes? Which are the parts you think is set for a change?
So I think if you see earlier, the upgrade was possible, and also based on the firmware and compatibility on the processors. The first step we are seeing is consolidation of the ECUs. If you see, the number of ECUs are increasing in our car today. That also is causing one concern from a functional safety and reliability point of view. To improve reliability, there's also one more technique of virtualization, where we're trying to see how we can, just like we did the same thing in our servers. Today, if you see, for everything, there is one ECU. Of course, it's also because of proprietariness introduced by some of the vendors. So we'll be seeing an evolution and a break there, where the technology will become a little bit more open and agnostic to the hardware on which they are running, and the sensors and the algorithms and the data, how they use data, will become the more important aspect for any subsystem provider.
I'll come to you, Omkar ji, and can you give us a sense what are the key external and internal changes that we will bring in a vehicle construction or design and development when we talk about a secure connected vehicle or safe and secure connected vehicle? Also, I would like comment from Mr. Raghvendra and Khushwant on the same question briefly.
Yeah, I think so. Fair point. I think we discussed example about over-the-air updates and difficulty and the challenges of that. One of the fundamental challenges is also the security, primarily because a lot of hardware in today's cars is a legacy hardware, and it may not be able to support some of the modern security requirements like hardware security modules or support for advanced cryptographic algorithms, for example. So if you look at fundamental, some of the design changes or infrastructure changes inside the car is to be able to support those cryptographic standards, to be able to support hardware security modules, to be able to support functionality like secure boot and those kind of things, that kind of forms the building block at the bottom. And then the second, it kind of goes into circles and layers on top of it, all the way up to, have you implemented adequate measures? Have you implemented adequate security precautions to kind of prevent attacks like man-in-the-middle attack, impersonation attack? Because when one vehicle is talking to another vehicle to get sensor data or to get data about the digital horizon or electronic horizon, or let's say you're doing a firmware download, are you really sure that you're downloading the firmware from an authentic source? Are you really sure, even if you're connected to, you talked about, connected to a Wi-Fi hotspot at Cafe Coffee Day, but are you still sure that your firmware is connected from a secure source? Are you really sure that your firmware has not been compromised or tampered with? How can you ensure that your firmware is current and it's not a stale firmware that has been pushed back to you? And then there are kind of layers and models of the security implementation. So what we follow at KPIT is, first of all, sticks to the basics, what is called as the TARA model, or threat analysis and the risk assessment model, where you analyze the attack surfaces, you build your threat model, and against the threat model, you build your security implementations. So first and foremost, that software development methodology has to embrace. You need to bring in new learnings. You need to bring in all those components into the car, both from a hardware perspective and the software perspective. The hardware basically enables accelerating implementation of certain security algorithms, cryptographic algorithms. It allows you to securely store certain data, for example, cryptographic certificates. So where do you store your keys? Where do you store your certificates? All of this has been done and solved on the enterprise side, on the network side. But all those constructs, all those technologies now to be inside the car. So your hardware needs to be capable of securely storing the cryptographic data. it needs to be capable of securely accessing it and granting access only to secure trusted software components. And also when it is booting up, it needs to make sure that it is booting up from a firmware that was the right firmware that was flashed into the car last time. So these are some of the infrastructure and software changes, which are like very, very obvious and straightforward. And there are a lot of advanced techniques and technologies that we focus on. From outside the car perspective, I think you have a mirror of that. But obviously, the enterprise security and the cloud security is far more established because we have been running, for example, all our banks are running on digital networks. All our financial institutions, stock exchanges, they are running on digital networks. And therefore, there are a lot of things have inherently happened to improve the security or the cyber security aspects of those. But in addition to that, you need to now kind of make sure that you are able to kind of replicate and embrace some additional standards which are specific to automotive communication, specific to automotive cyber security requirements. So I personally do not see fundamental infrastructure change onto the offboard side or the cloud side. But yes, there is a fair bit of change from an architecture perspective that needs to happen ground up, because you can bolt on security. Security has to be designed in, from grounds up. It's not something you can lift and shift and hope that you've covered all the bases. Because attack can come from a simplest thing like your USB. If you're carrying songs on a USB stick, you can intrude the software by hacking into the metadata of the songs, or you can intrude it through your Bluetooth phone book, your contacts, if you've not taken enough care. And of course, now USB sticks are also new. Modern cars probably don't even have USB ports because you're just streaming music from, let's say, a streaming site. But are you sure you are connected to the right streaming site? Are you sure whatever the data is coming through, which otherwise you are not paying attention to, is not wreaking havoc? So the security infrastructure in terms of algorithms, cryptographic processes, hardware security modules, secure storages, all that infrastructure needs to come inside the car and needs to be complemented by software components and of course software development methodologies. Then you can kind of really look at, first of all, having made sure that you've covered all the bases, and then you have to follow a systematic approach of what is called as basically penetration testing. Or pen testing, where you try to break into every possible attack surface to be very, very sure that you've really covered all the bases.
Thank you, Omkar. Raghvendra, can you please elaborate on the design and development side? How do you test digitally or in a shorter time? Because testing these all aspects may take a lot of time if we don't do it properly, if we do not deploy right kind of software, right kind of techniques. So can you please give us a sense, how can we successfully roll out such connected vehicles? We have just heard Omkar pointing to huge challenges and a lot of limitations and a lot of possible infringement that are there.
To start with, I fully agree with what Mr. Panse has just covered. So this is really a big challenge for all the ecosystem player here. First of all, when we are talking about security and the infrastructure dependency on the security in a car, it really takes a complete re-architecture in the vehicle network system to make it secure. So like Panse said, it's not something that you can build on top of what you already have. In fact, if you look at the way how the vehicles have been developed so far, they were developed without keeping a lot of security considerations because there were not really so much of an interface that were open to the outside world. At best, what you had was an infotainment system that probably could play from your USB player, etc. But beyond that, the communication was very limited in a vehicle. But today we are talking about vehicle that can have different kinds of communication. The Bluetooth is a very, very common communication media. Along with the Bluetooth, we have the infotainment systems being open to Wi-Fi networks. We have GSM as well as cellular connectivity provided to the vehicle. There is a GPS network that is available to the vehicle. And of course, in some cases, USB as well in the coming vehicles. So which means there are multiple ways in which somebody can access the vehicle. It is not possible for somebody to think that attack can happen in only certain ways, because there is a wide area that is open for somebody to get into the system. And once you get access to the system, what how they can navigate through the different areas of the vehicle network and access the critical functionality. It is up to the expertise and the knowledge of the person that is trying to access the system. Now here there are two things that we can do. One is the architecture level itself, where we can focus on building the safety and security with the different techniques in place. For example, we could make sure that the vehicle networks, especially the critical functionalities of the vehicle, do not have any sort of connectivity to rest of the network, which probably are used mainly for the infotainment purposes. So this is a kind of separation that we have seen in many other domains, especially in aerospace domains, where the flight critical network is completely isolated from the infotainment systems that are accessible from the users. Now, by any chance, even if the user gets access into the infotainment system or the multimedia system through whatever means, he will be limited only to that area, and he won't really have access to the real critical network or the functionalities of the aircraft. So something of this sort can be built into the vehicle at the architecture level itself. And secondly, the possibilities of someone trying to attack through the open channels, like over-the-air updates, is something, an important feature of a connected vehicle. And you can't really deny this feature in the car because there is a possibility of someone attacking it. So in such cases where we don't really have a choice of disabling the functionality, like over-the-air updates, or maybe vehicle-to-vehicle communication, vehicle-to-infrastructure communication, etc., which we definitely need to maintain. So in such cases, we have to make sure that the entire canvas of our electronics and software are tested against the possible vulnerabilities and possible attacks from the outside world. Typically, the pen test, like Mr. Panse was talking about, is a typical approach that is followed to see that what if somebody can get access through this mechanism? What if somebody can get access to some other mechanism? So you're basically widely thinking about all possibilities and try to simulate those kind of attacks. There are different softwares available to perform such kind of attacks, and to make sure that there are no loophole or the open area that's available for somebody to get into the system. So this is these are two areas where we definitely can improve the security of the vehicle. However, this is not the only limited area. What we also see is that when we are talking about ADAS and autonomous vehicles, these systems have a lot many sensors that are built into them. There is a possibility of someone exploiting the weaknesses in these sensors. For example, you have camera sensors that are mounted in a car, and you have a very simple feature, or rather, yeah, I would say simple feature, that detects the lane detection. So if you go out of the lane, that car will automatically warn you. So for this feature to work properly, your camera should properly see the road. And now you know that the camera sensors has their own saturation limit. Like in the low light condition, camera cannot see properly. But at the same time, if you flash a bright light into the camera sensor, it goes into saturation. It cannot see for a while. Now, this could happen accidentally, in the sense that some headlamp from the oncoming vehicle is glaring on top of the camera, or this could be exploited by somebody. Maybe you took a bright laser light and flash it onto your camera, then your camera goes into saturation. So for a distance, it cannot really see anything. Now, it depends on the intent behind the person. So if your intention is to hack into the system and cause some damage to the person, there are many ways. Now, we already have seen this happening in the real world, where you probably heard about the cases where people holding the laser from the ground and pointing it into the cockpit of an aircraft. So this really had happened. So given these scenarios, we definitely can expect all sorts of mischief like this could happen to our vehicle, and which could also be part of the cybersecurity analysis. Fortunately, these are new age technologies where we already are thinking about cybersecurity and enhancing security of the vehicle. So by design itself, we're going to take care of these things as far as possible, or at least the alternates whenever such kind of weaknesses are being exploited. But like Mr. Panse said, we definitely have to start right from the architecture itself.
Thank you, Mr. Bhat. I'll come to you, Nakul. We have heard a lot of complication and threat that is going to be there when we talk about connected vehicle. You specialize in electric vehicle, that to a commercial vehicle, wherein telematics, that's a sort of connectivity solution only. How do you see the role of telematics in a connected scenario? And there could be challenges in implementation of telematics as well. In such a scenario, what's your advice? What's your guidance on that?
So the way we have been approaching this internally at our
Also, how
in our
different it is going to be the challenges in EVs, because in EV to have a connected solution is very easy, but how easy is it to sustain a safe and secure vehicle in electric vehicle? How different it is going to be compared to the traditional vehicle, which has a powertrain, you have motor and and already ECUs and all that are there compared to the traditional ones.
okay. So first I'll elaborate a bit on some of the differences that might be there for an electric vehicle compared to a conventional fuel vehicle. What we have seen is that for electric vehicles, as I mentioned earlier, also connectivity and telematics would be an indispensable part rather than an add-on, because the battery packs and many other parts would need a constant monitoring throughout their life to ensure adequate performance as well as safety. Now, in the vein of keeping things simpler and not complicating them a lot, what happens is that, and I think one of the panel members also mentioned about consolidation of ECUs earlier. It makes much more sense to introduce these interfaces itself that can be prone to any kind of a attack from an external agent. So you definitely have a battery management system, which is a digital board, and you have a motor drive, which is another digital equipment besides the ADAS and other auxiliary systems ECUs that are there in the conventional vehicle also. So what we see is that an onboard computer comes into place, which interfaces with the BMS, the drive, for the fundamental function of driving of that vehicle and its mileage. And this onboard computer also needs to gather data from other ECUs that might be there. You can consolidate or virtualize a lot of them and make them maybe a parallel thread running in that onboard computer itself. But there would be this onboard computer which need not directly be connected to internet and can have a separate connectivity module or a telematics module which provides you that internet connectivity and is actually have the ports open to the outside world. And essentially then the problem comes down to providing all the protection and cybersecurity for this board, because this is the one that will enable over there updates as well as will uplink all the driving data and vehicle data to the cloud. There can be other interfaces, as they were mentioned, Bluetooth or radars or cameras that can be compromised, but those are a little ahead for many of the electric vehicle applications that we see in the country today. Right now, the highest focus is on the protection of the existing ECUs that are already there and adding that same security features to the BMS and the motor drives.
Thank you, Nukul. I would request the audience to keep posting their questions in the comment box. Our speakers are available to take them and they will individually answer all those questions. I'll come to you again, Umamaheshwaran ji, and understand how is it going to be like when we used to produce a vehicle or design and develop a vehicle in the earlier time when connected was not there, so much of electronics was not there, the distribution of resources were different. How do you see the resource deployment now shaping up for any OEMs or manufacturers?
Actually, a very interesting topic which we have been thinking in our management meetings on. When we go for connected vehicles, what is the skill level available within the organization to handle connected vehicles? There was basically a discussion point which was initiated by our MD himself as to, just like Modi has got Skill India, we have got in Punta, we got Skill TML, So we have to skill ourselves, because it's not about only few people like me and my team knowing about it. It's about service engineers, dealerships, also the end of line. If you see, we have trained more than 60, 70 people in our Tata Motors for the end of line, where the number of tests we need to conduct on this kind of vehicles on the end of line before we put the OK sticker on the vehicle has increased like anything, because we need to flash multiple issues. You also now put a telematics unit. You have to ensure that the eSIM is properly enabled, the certificates are posted, and then the VIN number and the VC number are married, and then it's updated onto the database. which is given to our dealership for tracking their vehicle. So this actually becomes a very important aspect for vehicle tracking in the yard or in some place where it is still waiting to be dispatched to the end user and so on. So this skill, if we see from a skill point of view, something that really, from engineering research point of view, yes, we need to add a little bit of extra skills in software testing and also in hardware testing methods. Okay, and also trying to put smart people who can create more failure mode scenarios, because our DFMEA, FMEA, all these things become much more, we need to strengthen that. And coming to the processes which we need to deploy.
Focus of R&D or engineering was to improve the hardware part, maybe lightweighting or anything. Now, in the last 1 decade, we have seen the change all around the world, and India has now started adopting to those changes. In such a scenario, what is the breakup of resource allocation?
Actually, if we are trying to reskill our people, because it is impossible to get a new fresh software engineer to know hardware and hardware engineer to get onto the software aspects. So we need to have some people who can be multi-skilled. So I feel multi-skill is the best solution. So that's what we have done in Tata Motors. They seem to be having some amount of knowledge already of the IITs and some places. Curriculum is no longer a magic science. Is now becoming available to almost all the community members. Thereby, we will be in a position to, as a OEM, exploit and use those talent, available within our workforce. Whereas earlier, in some technology which was not available, it was not taught in the university, so we have no option but to build it within the campus. When I say campus, I mean Tata Motor campus. So now there are some advantages we are trying to see, especially because of the updates happening to the curriculum of the various educational institutes in India also. So I think if I remember earlier days, we remember robotics used to be one such area where very, very few universities in India used to offer that kind of a stream. And you need to hunt for these people only in the US universities or in German universities. Whereas now, machine learning is omnipresent. So that is one good news from an India perspective. So coming to skill from the dealership, there are two kind of skills. One is no go kind of thing. Means you should be positioned to use the components provided to the or gadgets provided to the service engineer, plug them in properly, and run a piece of software which we develop and give it to the dealership, and that software does the complete diagnostic and gives a no-go kind of a output. So this for this kind of people, the kind of skill which is required is totally different from the people who develop this kind of system. So we segregate these two baskets. Luckily for us, the ratio is say 1:20. Means if there is one guy developing the software, there are 20 people who are going to use it. So and these people are going to be predominantly within the automotive factories in the end of line, or they can be in service engineers, or they can be in the dealerships. These are basically the kind of skills we are trying to see required for managing and maintaining connected vehicles.
Okay, let's turn the discussion towards another aspect, that is only safety that we talk about. Uh, India is capital of road accident deaths. If we talk about that, we have the highest number of death due to accidents, and mostly involves an automobile. So I'll come to you first, Raghvendra, and then I'll seek comment from Khuswant also. Raghvendra, how do you see these connected features or connected technology help us providing a safer vehicle or safer mode of transportation, and probably reduce the road deaths that we have because of the road accidents?
So today, if you look at the major incidents that we see happen around the roads, is primarily because of the lack of attention from the driver. Many times it's a careless driving, and the ratio that you can attribute to the vehicle itself that's contributing to the accident is a far lesser than what humans contribute to it. Now, this could be due to many factors, but what's important when you talk about connected vehicles is that these systems exist to help the driver to overcome certain challenges they face today. For example, many a times these drivers are overworked, especially when we are talking about trucks that are being driven on our national highways. We hear that the drivers continuously driving their truck for hours together with very little rest in betweens and so on. So these are some of the important challenges that we need to address. And when we're talking about this connected vehicles, they have a very good potential in improving these situations. Like especially one of the important application of connected vehicle would be, let's say, something like truck platooning, where you have a series of trucks that follow one another, where they can automatically decide what distance they want to maintain from one another. In addition to providing the benefits in terms of improved fuel efficiency, it also improves the safety to the overall scenario. For example, the lead truck driver, his vehicle will automatically communicate with the rest of the trucks that are following the lead vehicle, so that they communicate with each other at what speed they are going and what distance they need to maintain. And in case if the lead vehicle has to stop or slow down or accelerate, that information gets communicated back to rest of the platoons, so that they can, even though they cannot really see what's happening, it is as if like even the vehicle somewhere in between can really see what's happening around. So this way, the connected vehicles instantly provide benefits to the trucks that are being driven on highway. Similarly, when it comes to the private vehicles, what if you get to know what's happening half a kilometer ahead of you, that there is some intelligent system that warns you that there is another oncoming vehicles in a cross in a blind spot that you can't really see. So you don't really try to overtake a vehicle in front of you. So you slow down and go behind him so you can avoid the accidents. And this kind of information is going to be very useful to improve the safety of the vehicle. And the second aspect is definitely improvement in terms of the performance, in terms of the fuel efficiency and so on. Because some of the cases that I've heard about our customers are working on are like, for example, when you put a map on the GPS, like you want to go from place A to place B, the GPS knows not only the route, but also the road profile. And when you know the road profile, you know that there is a decline a couple of 200 meters ahead. You don't really have to switch to a lower gear and speed up the vehicle and then brake and then slow down. Rather, this information can help the vehicle to automatically decide that I don't really need to accelerate. I can go slower and then take the decline there ahead. So this kind of information will also help vehicles to improve the overall performance, reduce the fuel, increase the fuel efficiency, and also improve the overall safety of the road network. So that's my belief.
And driving experience can be improved if you are well informed about what lies ahead. Coming to you, Khuswant and Omkar, just want to understand how in-vehicle communication, connectivity within the vehicle, like your brakes talking to your gear system and so on, so forth, how this is going to improve the safety of the vehicles and the people who are using these vehicles or those who are walking on the streets. How can connectivity within vehicle improve the safety?
So maybe I'll answer in a different perspective. So networks are evolving certainly. It started with LIN in past, then moved towards CAN. Now we are looking at the bandwidth limitation currently to really achieve advanced features like ADAS or autonomous. From the in-vehicle network perspective, is there are several bandwidth challenges with the current CAN networks. So the options that are available are CAN FD, FlexRay, and going forward automotive Ethernet, and these are being explored as we talk. A lot of OEMs are looking at ADAS and autonomous areas of network where there will be very heavy communication between the ECUs. It will be taken over by Ethernet networks. If maintaining a hybrid network is possible, then the low bandwidth networks or communication will be handed over or taken or considered within the CAN perspective. But all of this, when we look at the impact on safety, the real timeness of the safety features is extremely important. And that's why bandwidth crunch on the in-vehicle network is a serious note. The moment bandwidth consumption or goes beyond, let's say 40-45%, of the available bandwidth, OEMs really start feeling the pressure because they do not have any redundancy later on to have any hypercritical communications or add even a single feature for future use cases. So scalability of the architecture, maintaining real-timeness even with this limited bandwidth, and additional new features coming up is going to be the key. And all of these connected features are certainly going to help to the safety of the vehicle. The single reason being, all the active safety features that we talk about today are basically driven by electronics. So be it anti-lock braking system or hill assist or airbag systems, or be it active or be it passive safety system, driver assistance systems, all of these systems are actually electronic systems or mechatronic systems. That means there is a lot of electronics. That means there is a lot of information that will be exchanged within this electronic control units.
Okay.
All said and done, there is no escape from improving the network and making them scalable for future to achieve safety in the end.
Thank you. Thank you, Kushwant. I'll come to you, Omkar. Your thoughts on this?
I think I would also probably take just a minute to also respond to one of the previous questions in terms of, you talked about the safety in the Indian context, right? We heard about some examples in terms of blind spots and how the connectivity and the vehicle-to-vehicle communication will improve. So these are being tried out, and these are little bit out in the future. But from KPIT perspective, for example, we launched a solution focused on journey risk management. So the journey risk management module, the simplest example is it will alert the driver that there is a school ahead and you want to slow down. It's a very, very simple but extremely powerful example. And how we want to do it is by announcing it through an audio box using an Indian vernacular language. But this is possible only because of connectivity. Otherwise the driver has no clue. Even if they know the road, they are traveling on that every day, you forget you are engrossed in something. But what this does is just makes the driver aware about what is the environment around. So I just wanted to respond to that. Bringing it to the onboard components, and I think your question is about how the communication between the components will add to the safety, right? So as Kushwant said,
You see that will have connectivity going forward. Right now, you have only few components, connected.
Yeah,
But
yeah,
see this progress.
yeah. I think
Do you see your axles talking to your brake going forward?
Right. So I think let me put it slightly differently. I think in today's architectures, all of you have sensors and actuators in a car. The sensors are picking up data, and actuators are doing the actuation job, like applying the brakes and things like that. The communication, I don't think the communication will get component to component, but the communication will certainly get intelligent. For example, today, what's happening inside your axle, what's happening inside the gearbox, and let's say your brakes, and the way you are accelerating, these are discrete functions. And the brakes are being controlled by maybe your ABS control module. Your engine management module is driving the actuators and the sensors related to engine. But the way the ECU consolidation is being driven, we see that vehicle networks itself evolving into Ethernet coming into cars. And we are not talking about simple Ethernet. We are talking about things like time-sensitive networking, or TSN. So you have highly deterministic and time deterministic communication, complemented by technologies like DDS, where you can distribute the data at scale within the sensors and within the vehicle. So what we have been focusing on at KPIT is what are the applications of TSN? How would sensors and actuators communicate? And what are those edge compute algorithms or edge compute intelligent pieces of software I can write at the intersection, which will make my brakes more intelligent, or which will make my engine more intelligent based on the brake data, which otherwise today they are not kind of talking to each other. So I don't think they'll talk to each other directly, but certainly they will start talking, and there will be a lot of edge computer applications which will make, let's say, the way you accelerate different, but depending on maybe the life and state of your brakes, for example. So a lot of these applications will continue to evolve. A lot of these applications will come because there will be ECU consolidation, there will be high-speed networks, and there will be time-sensitive networking coming in, which will allow large amount of sensor data to be captured and processed and redistributed and acted upon almost in real time, which today is just not possible. And again, you cannot have too many sensor or component to component communications, right? Because otherwise, who listens to whom, kind of, simply put. So what you need is some kind of a broker or a mediator or a supervisory control in between. And these supervisory controls are already becoming mainstream features, at least in electric vehicles. The supervisory control simply decides how do you apply the acceleration depending on the demand and the battery management system and the state of the battery, so on and so forth. So I think these concepts will evolve, and the culmination of edge compute, ECU consolidation networks will allow us to have sensors becoming intelligent, but somebody else kind of how can I say, disseminating the information and the decisions rather than it is being happening between discrete components.
Like to add one thing to this question, last question, Nabil, if I may.
Yeah, briefly, very briefly.
Yeah, briefly. So I think already there has been a conversation around how the network in vehicle networks will develop and progress. There is one another aspect that I like to quickly touch upon is the digitalization of many of the interfaces. So for example, and definitely in electric vehicles, what we are seeing is that going ahead, we'll have an electronic differential. So that will eliminate the mechanical gear differential that we have. It reduces mechanical losses and gives us more control on turning. Then things like brake by wire, throttle by wire will become mainstream because now a motor drive is going to come into place, which has a control law and which needs a throttle input as well as a brake input also. So brake by wire, throttle by wire, and then steer by wire, because if we have to eventually go towards autonomy, then the steering also will need to be digitally controlled. And this consolidation will of course happen on the ECU front, but the digitalization of these interfaces is also a trend that we'll see in coming years.
Thank you, Nakul. Khuswant, you probably want to make a comment? Yeah, a brief comment.
From the cybersecurity perspective, we missed an important aspect in the entire discussion, and I was waiting for the turn but we shifted the discussion to safety. So sorry to get you back to the topic. What is going to be an important change on need for implementing cybersecurity in any organization is the OEM driving a cybersecurity process. When we talk about infrastructure and system, there will be a lot of changes. That's understood. It's technology after all. But from process perspective, there will be a security organization team or a role completely taken over by certain team members in the entire organization. And second part is the incident response infrastructure. So these two aspects are extremely important, and UNECE WP29 guidelines, which are very recently adopted last month, already recommend that OEMs should have a certified cybersecurity management system. Main recommendations are having a security organization to prove what security measures are taken. And second, more important recommendation is to monitor the security of the vehicles in field. And that's where I think OEMs like Tata, who have export business in some parts of European Union, are directly impacted.
Thank you.
That's about it.
Thank you, Khuswant. When we talk about India, here the cost matters the most. So I'll come to you, Umamaheshwaran ji, and understand also from Raghvendra, because you are the part of the design and development solution provider. So just want to understand from you, Umamaheshwaran ji, is that the connectivity is still not proliferating in India because of the cost implication? Or do you think that the usability of connected feature is still very less? What is the reason, and how do you see the connected features pacing up in Indian mass segment vehicles going forward?
I think it's a cost and functionality is like a first chicken first case. So I think it's basically how customer views a feature on the car. For example, many years back, ABS had a lot of safety and accident cases because of the evolution of technology, and people started propagating, and each brand started giving negative propaganda about a feature itself. So like this, for every new feature which comes into the market, not necessarily in automotive, even you take what kind of bashing which happens between Android and iOS users. So it's a general thing which happens in in every industry. So coming to the usefulness is basically how to make it simple. So if you see in my last conference which I was there in Bangalore, I told it's not about connected vehicle. In fact, I like to not propagate about connected vehicle. I just want to give connected features. So what technology goes behind it, how it is done, whether we use ISO 26262 or what kind of processes we use, they all go transparent to end user. And of course, typical end user mentality in India is I want it free. Means I like to get everything in the same bundle price. So it's also a question of how we have bundled the connected vehicle features into our vehicle. It's actually different automotive companies have got different strategies. Some people say your basic car is this much plus add-on is so much. But some OEMs may decide to say, like our colleague in the panel, saying that connected is a integral feature of my product. It can't be removed. It is a part of my core system. So the way the pricing gets done is, you can say, yes, this vehicle comes free of charge of connected vehicle features. But actually the price is distributed among the remaining components. So it's the question of how you package the entire solution to the user from a price point of view. So whether it's free, not free, those things are, for example, if you see one typical example, how iOS gets upgraded and how the cost of iOS upgrade Apple is distributing on the cost of the Apple phone or the iPad itself is a very typical example of how the cost management is done on the life cycle of the TCU. Suppose I charge a vehicle with the total development cost over a period of say 6 years. So apportion that and say this is going to be the cost loaded onto the basic per vehicle itself. So it is taken care of. So the question of how packaging gets.
Please allow me to interject. I just want to understand from the customer side. Do you think the customer have queries about cyber security when you offer them a car with connected features? Is
Actually,
that
more than cyber security, they are a bit concerned about the privacy issues. They want to ensure that their location is not tracked by anyone. They want to ensure that their playlist or their frequently used some addresses or telephone numbers is not visible. So I should not say from a cyber security point of view, from a privacy point of view, even for the cloud operator who's going to manage the connected vehicle data. So these are some of the I should say concerns of the smart users, but most of the naive users, I should put them around 90% or so. They are more interested in the functionality working correctly. So many times we get these problems in Tata, Tata Nexon or what other vehicles we have today. The vehicle gets parked in a place where there's absolutely no 2G or a 3G or a 4G network connectivity, and you expect the AC to be put on, and it never puts on. So people get very frustrated. But at the same time, the infrastructure in India, especially the cellular data network, is going to be a very big decision maker in making sure the connected vehicle becomes a grand success. I may put any amount of effort in testing, in giving the best possible TCU with an amazing edge computing capability, and also have a very clean, SSL kind of a secure tunnel from my TCU to the cloud, and ensure everything is done. But at the end of the day, when you park the car in a no-network zone, we can't do anything about it. And that's what is the most, I should say, statistically speaking, 90% of the users are concerned about functionality. If I promise that by the time I walk from my home to that parking lot, which is in my society, slightly few meters away, that I put the AC on and it has to work. So if you see our reviews nothing is closed now. You can go to any of the websites about Tata Motors. You can see the kind of feedback we get is predominantly on functionality. Cost is there. Some people are they want everything free. So that's but usual in India anyway. So not only for cars but for everything else too. So functionality first. Of course, price is India is price sensitive, so we need to manage that within the available base vehicle cost, which we are going to create.
But I think it's the biggest challenge for connected vehicles is going to be the willingness of customers to pay for software or software upgrades. We are habitual of using software for no cost, or we always try to find a software at zero cost. So I think that will be a big challenge for the OEMs and the vehicle manufacturer going forward. And thank you so much, everyone, for joining in today's panel discussion and giving such an elaborate and holistic view of the safety and security challenges that lie ahead when we talk about connected vehicle. if there are challenges, you have completely, echoed that there are opportunity and advantage also that is going to come to the table with connected features that are going to power our vehicles going forward. Thank you so much once again for joining in. Viewers, stay tuned. Coming up a next presentation on the connected vehicle that is going to be equally enriching and engaging. Thank you so much once again for joining ET Auto panel discussion.
Thank you very much.
Thank you.